predictive analytics and prescriptive analytics. I think all of you have heard about this term, descriptive, predictive, and prescriptive analytics. In statistical language, we basically use two analytics we call descriptive statistics. Second one is inferential statistics. So I covered this from the idea of data science field. So, you know, in the data science, we also cover the statistics areas. So basically, if we talk about the data analytics, whether you are doing research work, you are doing business intelligence issues, or you are doing any other analytics for any purpose, you need to cover these three areas. As a whole, we call descriptive, predictive, and prescriptive analytics. So I'll go one by one. Number one is descriptive analytics. Here you see what it is. Descriptive analytics basically tell you what's going on, what's happening. If you want to measure the current scenario. So suppose you are collecting data about any respondents. So you want to show the data where's the average, or where's the mood, or we call deviations from mean values. If you want to show that, that is regularly we are doing in business organization also. Like in the business organization, organizations are collecting data from lower level managers. In the business intelligence field, we call the lower level managers are creating data, mid-level managers are converting this data to information, and then top level managers are making decisions based on the informations. So though this is, we are aligning this with the business intelligence, this is also applicable for research work also. In the research work, you see, you are designing your research, then you are collecting data, and after collecting data, then you are basically applying some tools to convert the data to informations. So descriptive analytics basically help you to make your understanding about the current situations. Like if we talk about mean or average, through mean or average, you can understand what's the current conditions of the data. But in case of predictive analytics, if we talk about the predictive, you see, it is kind of inferential statistics. We are talking about what's going to happen. That is, we don't know about the future, but based on the previous data, we can predict what's going to be happen. And we are using some tools to do so. That is regression analysis. We can do forecastings, or some other tools are there. In data science, we use data mining, text mining, web mining, lots of tools are there. But predictive means we are predicting what's gonna happen in future. And in case of prescriptive analytics, as you see, this is same as prescriptions. Like in the doctors, when you are visiting the doctor's office, they are diagnosing you, and then they are giving you some prescription. That is, what should you do? So based on the problem, you can prescribe some solution by analysis. This is more advanced level analytics. So in the research field, usually most of the cases we are covering only the descriptive analytics. Very few are using the predictive. So if you have the capacity to cover both descriptive, predictive, and prescriptive analytics, then in the data science field, we call you a data scientist. That is, you know how to convert this data by using the descriptive, predictive, and prescriptive analytics. As I said, I'm covering the lesson from two perspectives, not only from research perspective, I'm also covering this from data science perspective also. So if you are experts on descriptive analytics, then we call you are analyst, business analyst. That is, you know some analytical tools, so you are data analyst or business analyst. But if you know about predictive and prescriptive analytics, then we call you are data scientist. So I'm giving you another example, like think about the business organizations. In the business, organizations are collecting data, their day-to-day data from their ERP, we call enterprise resource planning. That is what's happening in the day-to-day activities. You know, there are various functional areas like finance, accounting, marketing, HR. So in every functions, what's are happening, the organizations are collecting this data through some systems we call TPS, MIS, DSS, ESS. These are some systems organization basically use, and these are we call regular analysis on the data. So these give them insights, and based on that insights, they are measuring their KPI, key performance indicator, that is whether their organizations is performing properly or not. So this is about the descriptive analytics. But if organization wants to cover some predictive analytics, like you don't know about your future customers who will buy your product in future, or suppose you have last couple of years sales data. Based on that, you can forecast what's going to happen in future through forecasting, or you may develop some regression modeling also. So that is we call predictive analytics. And prescriptive, as I said earlier, that is this is prescription. So if you want to do suppose prescriptive analytics, you can apply some data we call management science related tools, linear programming, and some advanced level tools are there, simulations and others. So these are the basic distinctions about descriptive, predictive, and prescriptive analytics. So in these area, we can use some tools. I will cover one by one. Before that, as you see, to analyze the data, you need to know about the data types. Here you see in the data. So data might be in various natures. It might be numerical, it might be textual, or some other format. So whatever data you have, you can categorize these in two natures. One is structured, another is unstructured and semi-structured. Structured means we call if you pre-plan the data, that is data stored in a systematic manner. So you are collecting data in a systematic manner. So this is structured. Like business organizations are collecting data about their functional activities, that is we call structured data. But semi-structured and unstructured, like these are not routine work. These are not predefined. They are collecting data from their web sources, social medias, and some other external sources. It might be XML file or any web-related file also, and multimedia and textual. So these are unstructured or semi-structured. So for unstructured and semi-structured data, we basically do qualitative analytics. And for structured data, we are basically using quantitative analytics. So as you see in the structured data, we are categorizing this in two types. One is categorical, another is numerical. In case of categorical, we have two types. One is nominal, another is ordinal. And in case of numerical, we have interval and ratio. So nominal data, that the data which you cannot classify in various classes, like your name, but your gender. But ordinal data, suppose if you can classify that data in various class, like if we talk about suppose your position in the organization, whether you are holding the positions in the top level, mid level, or lower level. That is, you can categorize in various types. So that is we call ordinal data. And here, in case of numerical values, we can do that through interval and ratios. So I'm just explaining this idea more clearly on the next slides. Here you see, in case of nominal data, this is only named variable. There is no order. But ordinal data, this is named and ordered variables. In interval data, you have named, ordered, and we call proportionate interval between intervals. Like if we talk about students' grade, so students' grade, covers here marks are different. If we talk about A plus, A, then B plus. So these are grades based on some intervals. And we have ratios, that is we call name plus order, then proportionate interval, and then you can, of course, accommodate the absolute zeros here. So I'm just explaining these 4 level of measurements through some examples. So these are important for you, because if you don't know what kind of data you are dealing, you aren't able to present the data. Data visualization is very important for any research work or any report or presentations. So if you don't know what kind of data is appropriate for what kind of graphs and charts, what kind of tools, then you may come up with some ambiguous presentation, or you cannot explain the idea to your audience clearly. So as you see, in case of nominal, we call this is discrete. Discrete means that can be defined. Like if we talk about binary, suppose in the digital, digital works through digit. So if I ask you how many digits are there, you can easily tell there are 2 digits, 0 and 1. 0 for off false, 1 for on false. So that's why this is discrete. That is here discrete data. But in case of ordinal, here you see we call we have continuous data. In case of interval, we have continuous data. In case of nominal and ordinal, we have discrete data. So I am just explaining the distinctions between discrete and continuous again. Suppose you have marks 1 to 100. These are we call here continuous data. You cannot define how many types of data are there. So you may call, okay, we can call there are hundreds data. So if anybody get suppose 70.5 or 60.4, so we call lots of data are there. This is not defined. But when you are categorizing this data in various class like grades, so we are covering this. If anyone gets 0 to 40, then F grade. So this is one class. Then we call D grade, C grade, or some other grades are there. So when we are defining these numbers in specific classes, then it becomes discrete. But when data are presented here in normal format, then that is we call continuous data. Another example, suppose you are collecting data from respondents on the, suppose you are collecting respondents' height, respondent weight, or suppose you are covering number of miles you travel. So all these are actually continuous data, but you can convert these as discrete also. Suppose if we talk about human heights, how many heights are there, we don't know, but we can categorize this. Suppose we can categorize this 1 to 4 feet as value 1, then 4 feet to 4 feet, 5 feet as value 2, then 5 feet to 5 feet 5, value 3, then 5 feet 5 to 5 feet 11 or 6 feet, value 4. That is, we are categorizing in specific classes. Then we call that is here our discrete format. Now, if your data is in discrete format, then you should use bar chart or pie chart. So this is very clear. Suppose you are presenting data. Suppose I can give you another example. Think about cricket score. So if we are presenting the batsman's score individually, 11 players, we can present that through bar chart, through pie chart. But when we are presenting the total score, that is the team's run, suppose in 50 overs, team scored 350 or 400, whatever, we are showing this over by over. There is no gap between one point to another point. So this is continuous data. On such case, we will create histogram or line chart, or there are some other tools we can use there. So basically, you need to know about this discrete and continuous data to understand what kind of charts and graphs you should use. And of course, here you see in the descriptive statistics what kind of tools you can use for different kinds of data formats or measurements. You can do that. So as I said, you can convert your here continuous data to discrete data. You can classify this. Here you see I am giving you another example here. Suppose you are talking about nominal data, like Rachel is tall and Gregory is short. So this is different format for form. We call two different persons. So you are talking about two different persons' height. One is tall, another is short. And when you are comparing one to another, that is ordinal. We call Rachel is taller than Gregory. So you are comparing. So in case of ordinal, that is you are comparing one data to another data. And in case of interval, here you see we call Rachel is 5 inches taller than Gregory. In the previous case, like in ordinal, we didn't mention how much taller Rachel is from Gregory, but in the interval, you are telling the exact hair distance or exact inches that Rachel is greater. And then in case of ratio, you see Rachel is 5 feet 10 inches and Gregory is 5 feet 5 inches. So same data you can present in various natures. So how you are presenting that basically defines what kind of analytics or what kind of steps you can take. So when you are collecting data, that is on your research design, or when you are designing the questionnaires, of course, you should think about these issues. That is whether you should collect data in ordinal format or interval or ratio format. Like suppose if I tell you one thing, suppose you are measuring the customer satisfaction, you can ask them direct questions like, are you satisfied with the services of our product or services? Like straight question, yes and no. So yes for one, no for two. But there might be something in between. You can do that like here through a scale. You can measure this through like a scale, highly satisfied to highly dissatisfied. Even if we talk about some measurements in various product reviews or service reviews, if we talk about our Uber service, you know you are giving the feedback through this scale. If we talk about IMDb International Movie Database, you are providing feedback based on scale. That is whether the movie is excellent or it is bad. So there is in between good or bad. That is you are not sure about the service. So if you just put that on straight yes no, that means you are not able to analyze this data in scale format. But if you put questions in these kind of measurements, like you are providing data in scales, then you can do lots of analytics there. Now, as you see, as I said earlier, in the analytics field, we have two fields here. One is we call statistical analysis. In the statistical analysis, basically we are covering two kinds of statistics. One is descriptive statistics, another one is inferential statistics. So in case of descriptive statistics, already I said about that. Is descriptive covered only the what's going on or what's happening, the tools we are using like mean, median, mode, standard deviation, percentage, frequencies, ranges. So these are we call descriptive. And inferential, that is also known as we call predictive analytics. We can do that through correlation, regressions, ANOVA, and some other tools. So I'll discuss these one by one. Number one here is descriptive statistics, measures of central tendency. So number one here, descriptive. Here you see you can analyze the arithmetic mean. So you know how to do that. As I said, in this short session, it's not possible for me to explain all these. As you are working on research field, definitely you know about this, what's the functions. So as you are collecting data, you need to know where you can apply the analytics or what kind of analytics you can apply for what kind of data. So it's very important for your data analytics. Like sometimes you are applying mean in irrelevant data. Suppose I can give you one example. Suppose if you apply mean on gender. So suppose you are defining male for 1 and female for 2. Now, if you add this number, you will get between 1.5 or something like that. So you need to know where is applicable, whether mean is applicable in what kind of data and through which you can make what kind of decisions. So as I said, these tools are basically tell you what's going on or what's happening. Suppose you are measuring the average grade of the class or average grade of a group. So average here we call CGPA. So suppose you are collecting individual scores and then you are averaging that. So it basically helps you to make one decisions. Suppose you covered that the average CGPA of the class is 3.5. So you can understand that the class level is good or bad. Suppose if the average is below 3, then we call the class performance is not good. But if the average is above 3.5, then we call class performance is good. And same thing happened for organization analysis in the business intelligence. When we are measuring the KPI, whether you are performing well or not, we can do that simple by collecting sales figures. Suppose we are collecting the daily sales figures, weekly sales figures. So we can measure the average sales. So we can compare average sales from day to day, week to week, or month to month, and we can measure what's the performance of our organizations. So same thing we are applying in the business organization, and we are applying in the research field also. So this is about mean. Second one is median. Like you want to know the middle value, so you can do that median. And mode, we call the number that appeared most. Suppose you are talking about the students who appeared most, or we call in the attendance card who came regularly. You want to identify that, so you can do that through mode. So these are we call mean, median, mode, and then we have dispersions. Here we call this is degree of variation in a given variable. It could be range here, variance. You know about these here formulas. In the standard deviations, we have these formulas. So deviation is important. Like suppose if you want to show the value, that is how much deviated your values are from mean value. Suppose I am telling you the CGPA of one class is 3.3 plus minus 0.5 standard deviation. It means the upper range could be 3.3 plus 0.5, that is 3.8, and lower range could be 3.3 minus 0.5, that is 2.8. So the lower the deviation, the better the nature of the data. Suppose I can clear this idea by giving you examples. Suppose in a class, you have higher CGPA, but deviation is higher. So the class might not perform well because you may have we call A class category and we call D category. So when you are delivering lectures, A plus category is receiving lectures very quickly because their understanding is very sharper. They know about your delivery. So they are understanding that very quickly. But those who are in D category, so in the same class, it could be quite tough for teachers to deliver lectures thinking about both A category and D category. So if the class deviations, performance deviation is lower, like we talk about deviation is 0.2 or 0.3, that means the class performance, the students who is performing their performance, you may deliver better lecture in the class. So the standard deviation can be used in various purposes. Just I am giving you one example, like if you have lower standard deviation from mean value, then we call that data are more homogeneous, less heterogeneous. These homogeneous data definitely would assist you in various ways. Like in business organization can measures the sales performance and some others through these deviations. Then we have here, you see the box plots. Here you know about this, like you can present the data from mean, median, and mode, and who are presenting or who are here staying below the average or above the average in the upper quartile or lower quartile. You can do that through this box plot. And we have in the descriptive statistics, we have skewness and kurtosis, and of course histogram is there. As I said earlier, for continuous data we perform histogram and line graph. So if you have continuous data, you can present that through histograms, and you can measure the skew, how much your data is skewed, whether this is right skewed or left skewed, or the, you are working on normal distributions or not. You can measure that. Here you see there are some graphs. This is normal distribution. That is most of the data are here covering in the central part here. So this is normal, our curve shaped equally on both sides. So this is we call normal distributions. And we have left skewed and right skewed options are there. So you know about this, you can apply that. Now I'm going to the next part of our statistics or analytics, that is we call inferential statistics. As I said, in data science, we call this is predictive analytics. So in the predictive analytics, in case of data science, we are applying data mining, text mining, web mining. So these are some of the way. In case of statistics, we are using regression, then forecasting. So regression, this is part of course, inferential statistics. And this this is the most widely known and used analytic technique in statistics. Like if you want to measure say any impact, so when you are performing two variables, whether there is impact of one variable on another variable, you can do that through regression analysis. And it can be used for hypothesis testings or forecastings. Then we have here, you see correlations versus regressions. In case of correlations, you are showing whether you, your data is we call highly positive, or in the correlation we have three values we call +1, -1, and 0. +1 means highly positive relationship. So if you are measuring two variable relationships, suppose I can give you one example, sales and advertising. So if you have a positive relationship between these two, suppose you got the correlation value near to near to 1, you got 0.9 or 0.8 values as correlation values. So we call that is a highly positive relationship between advertising and sales. That is, the more you advertise, the more sales you will get. But in case of regression, we are actually measuring what's the impact of one variable on another. Suppose again I am citing the same example. You are covering sales and advertising. So what's the impact of advertising on sales? You can do that through regression equations. I'm just explaining the regression equations on next slides. So regression, here you see it could be simple regressions or multiple regressions. It actually based on a number of input variables. So if you see there are various independent variables which are impacting on your dependent variable, then we call there is multiple regression. You can do that. And here you see that how do we develop the linear regression model? It could be here is scatter plots. We call simple regressions. Linear regressions is theirs, and this is ordinary least square methods. That is, we call a line that minimizes the square of the errors. Now you see this is we call our regression modeling through we call linear regressions. Why we call linear? Linear means straight line. So if you put down point from first to last, you will see a straight line. That's why we call this is linear. So one thing I need to explain here, regression equations starts from what we call y equal mx plus c. There is no power in our variables here, y or x. So as you see in x variable, this is always, we always put down the independent variable in x and dependent variable in y. So if you have two variables, of course, we are showing through slope, that is what's the impact of x and y. That's why the equation is y equal mx plus c. Here c is constant and x is we call our independent variable, and m is our slope. So here it is mentioned as beta. Whatever you put, actually slope is, we call this is rise by run. That is what's the changes of y based on changes of x. So as you see on the equation, if we put down the value of x, we are getting the value of y. That's why we call y is dependent variable and x is independent variable. Suppose you are doing research on some variable, so you need to identify which one is dependent and which one is independent, and you may come up with multiple variables here. As I said, here you see the simple linear regression equations, y equals beta 0 or plus beta 1x. This is same as we call y equals here c plus mx. So beta 0, this is we call our constant. I can give you one simple example, like if we talk about the organizational cost. We call in case of cost accounting, we can do this like total cost equal fixed cost plus variable cost. So total cost is y, then fixed cost is here b0, and then variable cost is here our mx or b1x. So that is variable cost. So suppose fixed cost is fixed, whatever the amount you are investing, that is fixed. So but variable cost, it varies. Suppose to produce one product, you need to spend 10 rupees or 10 taka or $10, whatever. So the more you produce, the more variable cost you need to bear. That is, we call this is our slope. So suppose x to produce one unit, you need to spend $10 or 10 taka. So this is our variable cost. We call variable cost per unit is fixed and fixed cost per unit is variable. Later I'll explain that. That is if you just produce 100 units, always your variable cost is 10 taka, 1000 unit or 10 taka. But if we talk about the fixed cost, as you see, suppose you spend $10,000. So on your dollar here, if you produce 100 units, the per unit fixed cost would be suppose 10 taka. But if you produce 1,000 units, your per unit cost would be 1 taka. So per unit fixed cost. So that's how we call fixed cost per unit is variable, but variable cost per unit is fixed. So basically, while you are doing research, you need to show the relationship between two variables for these regressions. Here in the multiple linear regressions, as you see, we have x1, x2, x3, and xn. There might be lots of independent variables. So as I said, suppose you have 3 or 4 independent variables which is impacting on y. So you can measure that which one causes most. So basically the regression modeling is telling you the cause and effect, that is you are showing the impact of one variable and another on another. So you can present your analysis based on this regression modeling also. So as I said, there are basically 3 kinds of analytics. Whether you are doing analytics in research purpose, statistical analysis, or data science analysis, or business intelligence, or we call you are measuring the KPI. Whatever the natures, everywhere you can measure descriptive, predictive, and prescriptive analytics. So again, I am just covering the distinctions. If you do only the descriptive analytics, you are analyst or data analyst, or we call business analyst. In case of research, you are just covering only the what's going on or what's happening. But in case of predictive and prescriptive, I already mentioned about predictive analytics tools like data mining, text mining, web mining. In case of the statistical tools, we are using forecasting, then regression modeling, time series analysis. Now I'm showing you some tools that are widely used in the research field. Already we mentioned about techniques. Now we are talking about the tools. So as you see in the graph, this is a research findings. They just surveyed on some users, that is what kind of tools they are using. So in case of data analytics, R is widely used, and then second one is Python, then you have SQL, then Excel. So you have lots of other tools. So I would suggest you to work on here. If we just go to the next slides, here you see here are some tools. You have SPSS, and of course SPSS and Excel is very basic tools where you are storing the data, you are collecting data, you are storing the data systematically. But if you want to do research by using some advanced level tools, of course, Python, I would suggest Python. Python is one of the widely used tools. If you are expert on that, you can actually work lots of analytics. You can cover that area in various fields. So you may, some of my students always ask, these are tools for suppose programmers or those who are experts, those who know about programming language, they know how to code. Is it possible for us? Actually, once we claim these tools or techniques are for computer scientists or data scientists or statisticians. Now, as we said, we are living in 4th industrial revolution. So once we gathered knowledge in monodisciplinary format, now we need to learn multidisciplinary. So if you want to perform well on your career, you need to learn multidisciplinary skills. Like I can give you another example. If we talk about the oil security, or we call cyber security, once we claim that it is the functions of computer science students, or those who are expert on computer science. Of course, they are expert on that, but now we are living in a world where if you don't know about the security, whether you are doctor, engineer, you are CEO, you are university professor, whatever your position, you will face trouble. And like that, if you are working on her research field, so if you still work on only SPSS, so we call you are only the novice user, you are the basic users. So if you know how to use the R and Python, then we call you are advanced users. Of course, definitely through SPSS, you can do lots of here advanced analytics also. But to present data in more systematically, Python is better tools, and through MATLAB, or we call through RapidMiner. These are basically for data science related uses. In research uses, I would suggest you focus on 4 tools. Number 1 is SPSS. Number 2 is Excel, number 3 is R, then number 4 is Python. So if you are expert on these 4 tools, then you can claim that you are expert on data analytics. So whatever techniques you will use, you will apply that on these tools. So as I said, the session is very short. I just try to cover some techniques and tools of data analytics, data analysis. Now, if you, here is we call the data analysis tools. Already I mentioned about that. Now, if you have any question, you can ask. I will cover as much as I can. So please just introduce yourself first, and then ask questions.